This is the project where you will learn the most basic mechanics that are used in the most popular 2D games. All you need to know to follow along this project are functions, loops, arrays, and if statements. This is the first version of our game. You have a map that is represented by hash symbols, and then you have a pop-up message that asks you where you want to put your unit. I need to provide index, and similar to arrays, index are 0 based. I can put 0, and then I press OK, and now we see our align unit that is represented by A letter on the first line, and on the last line we see an enemy that is represented by E letter. Then again I can add a new unit. I type 0 and press OK again, and now you see that units are moving towards each other. The purpose of this game is to reach the end of the map, but when two units collide, they destroy each other. For example, let's continue, and now you will see how on the third line, two units will be disappeared because they will collide. And if I reach the end of the map, I have the message that you win, and I don't have pop-ups anymore. In the future, we will add more units and create a full stack application with graphics and multiplayer. What we need to do to make our game? First of all, we need to create a function that displays our map in the console. In the game creation, the typical name for this function is draw. Then we need to add allies and enemies on this map. Then we need to create a function with the logic of movements of our units. And last but not least is to create a winning logic. So we need to have a function that would check if we have a winner. And if we have, we need to stop this game. Let's create our map. And as you see, this variable should be string, but we will store it as a 2D array because we need to get access to each symbol independently. A 2D array is an array that contains arrays. I create an array, then I expand it by pressing enter, and now I will create a new array. And inside of this array, I will store hash symbols. This is a row and this is a column. And in one row, we have 5 hash symbols. So I will add 5 hash symbols separated by comma. And now this array represents our first row. After this array, I need to put a comma. I again press enter, and now I create our new array. And it will be absolutely identical because each row is the same. Let's add more lines. When I add the last array, I need to delete the last comma. And now you see that this grid is very similar to our map. This map is an array. This is not a string representation. So for the clarity, I will add array to the name of this variable. And now this variable calls map array. Let's write our first function. This function should draw our map. To do it, we need to convert our map array into map string, and then we need to log it to the console. So I create a new variable map string that is equal to empty string. And then we need to iterate over each symbol in this map array and add it to map string. We'll need to extend this string, so this is the reason why I changed the keyword const to let. And now I write a for loop. This is the most common loop to iterate through each item in the array. Usually we use arrayname.length property instead of 5, but now for the clarity, I hard-coded this value to 5 because we have 5 rows. As you remember, we can get access to each element by index. What we will have if I access to our array with index of I. For example, I is equal to 0. So I change the I to 0, and if we look at our array, the first element with index of 0 is the first line of this array, so the first row. It means that if I access to the array with I, it will give me a row from this map. Let's store this in the variable. And now we know that this row is a simple array that contains strings. So it means that we can iterate through this array again. For that, I will write the second for loop. On this time, my for loop is inside of another for loop, and this is the reason why I can't use the same variable's name, and I need to change our variable I to something else. By convention, if we write the second for loop, we use the name j instead of I. So I also wrote j less than 5 because this row contains 5 elements. And then I write j++ as we did with I. These two for loops are absolutely the same, but the name of the variable is different. If I access row with the index of j, I will get one of these elements. So it means that I can save it as a tile. A tile is simply a string, this one element from the map. Now we need to add it to our map string to display it in the future. If I just add tile to map string, I will eventually have a string with 25 symbols length, but I also want to separate them into each line. As we have in our map array, let's create a row of string and then we will add rows to the map string. I rename our variable row to row array. I also need to rename this row as well. After row array, I create a new variable row string. I use the keyword let because we will add elements to this row string. Now let's add a tile to a row string. Eventually this string will contain 5 hash symbols, and when we finish this for loop, we need to add this row to our map string. We also want to put each row on a new line, and for that we have a \n symbol. This symbol adds a new line, so it works the same as pressing enter on a keyboard. And when we finish both for loops, we can display our map in the console. So let's test our function. For that I need to call it. And now you see that we have a map in the console. Do you remember this overview? These are components of our game loop. The simplest way to implement a game loop is by using a while loop. I create a new while loop. I also add break keyword to prevent an infinite loop. So we need to write a condition for our while loop. So the condition while we need to play. And generally we need to play while we don't have a winner. Let's go to the top of our project, and before the map array, let's declare a winner. I create a new variable winner that equals to false, and I start from the keyword let because I know that in the future I need to change this variable to the actual winner. And now instead of the keyword true, we can use the condition while our winner equals to false. We also have a shortcut for this condition, which is a not operator before the keyword winner. So it means while our winner is false, so while we don't have a winner, we need to do something. And for example, we need to draw our map. So we can add this action to our for loop. All the further functions that we will create, we will add to this while loop. Now let's add some units on this map and write some movement logic for them. The first function is addEnemies with no parameters. This function always generates the same unit on the first row of our map. However, the enemies index will be chosen randomly. Let's start from the enemies index. I wrote enemy index equal to math.random. Eventually, we want to have the input from 0 to 4 inclusive. This function returns the number from 0 to 1, where the 0 is inclusive and the 1 is exclusive. So the actual range of this function is from 0 to 0.999. To extend the range of this function, I can multiply this function by 5. And if I want to calculate the result, I need to take both edge numbers. So the edge numbers for this function are 0 and 1. And then I need to multiply them by 5. 0 multiplied by 5 is 0 and 1 multiplied by 5 is 5. So the range that we will have is from 0 to 5. But the last number of this function is exclusive, so the actual range from 0 to 4.9999. We also want to have only integers, so math.random function gives any number from 0 to 1. But we want to have only whole numbers, only integers between 0 to 4. For that, I can round this function with math.floor. This function rounds the number down to the nearest integer. And to remember this function, the word floor can be associated with down. This function gives the range from 0 to 4.999, and if we take this last number and round it down to the nearest integer, eventually we will have integers from 0 to 4 inclusive. So I can write that this function returns any integer from 0 to 4. Then let's take the first row from our map and put the enemy on this row. Map array is a 2D array, and to access the first row of this array, I can use 0 as the index. But the row is an array that contains tiles, and I can access a specific tile using enemy index. I set the tile that we accessed by enemy index to E that represents our enemy. Actually, you can choose any letter that you like, but I choose E. Let's write a similar function for allies. I found that I named our previous function addEnemies, but actually we add only one enemy, so I will rename it to addEnemy. The structure of this function is the same. The first line, as we had in our addEnemy function, we need to get the index. This time we don't get the index randomly, we get it from the user. For now, let's assume that the user gives a valid index so we can skip validation. Of course, in the future, we should add validation, but now for the simplicity, let's assume that the output is valid. I want to show how prompt function works, so I will call this function in our while loop after the drawMap. And now you see that we have this map in the console, but we also have a pop-up message where we can type something. So for example, I can type 0 and then press OK. And in this case, my prompt will be equal to 0. All this function will be replaced by 0, but this 0 will be a string. But in our case, there is no difference that the response is a string, because JavaScript is smart enough to convert strings to numbers in the case when we use a string as a number. For example, in our previous function, if I try to access the tile with index 0, that is a string, JavaScript can automatically convert it to a number with a value of 0. A lot of other languages can do it, but JavaScript can. This is the reason why we don't need to convert our prompt to integer. In our addEnemy function, we accessed the first row because this is the first row and we want to put our unit on a tile on this row. If we're talking about allies, we want to access the last row and to put our enemy on a tile on this line. In this case, I access the row by index 4, because totally we have 5 rows, and we remember that indexes are 0 based, so it means that the 5th row index is 4. And now let's set an ally on a tile. And finally, we accessed the tile by ally index and set it to capital A letter that represents our ally. Let's think about movement logic for our units. Enemies should move down and allies should move up. Let's have a look on enemies. The logic that I suggest is to check the next tile. If the next tile is empty, we can remove our enemy from the current tile and then we can set it to the next tile. But if on the next tile is someone, we need to determine if this is an ally or an enemy. If this is an ally, we have a battle and we can just remove both units. But if on the next tile is an enemy, we have a problem. We can't put two units on one tile. So how to solve this problem? The solution that I found is to process units starting from the last row and moving to the first row. So for example, we have this situation where two units are close to each other. We can check the last row. If on this row is any enemy, we should move him down. We see that this row is clear. Then we go to the next row and we see that here is an enemy. So we should move him down. And eventually this row is clear. We go to the next row. Here we also find an enemy and we want to move him down. But now we know that on this row can't be enemies because we moved them down. So it means that we can move our enemy down, or if we have a collision, we definitely know that both these units are on different sides. So we can just remove them. Now we have a plan for our function. So let's write it in our code. The name for our function is moveEnemies. This function will move every enemy that is on the map. This is the reason why enemies are plural. Then we want to iterate through each tile, but we need to start from the last one. For that, I write a for loop with a starting index of 4. During this loop, we can get each row. So let's save it in a variable. And now to iterate through each tile, you have two choices. You can iterate from last to first or from first to last elements. At this point, it doesn't matter. Both solutions are valid. You can choose whatever you like, but for the consistency, I would choose a for loop from last to first element. So let's save this tile in a variable. I want to move only enemies. So let's check if tile equals to E. In this case, I know that the current tile contains an enemy and I should move him down. At first, I should check if there is any collision with the next tile. Let's write a new function enemyCollision to handle the logic of collisions. But we will complete this function later. Of course, we could write the logic of collisions inside of the moveEnemies function, but this is a good practice to give only one responsibility for each function. In this case, it will be easier in the future to understand what this function does, and it will be easier to debug it. When we call moveEnemies function, we only want to move enemies. We don't want to have any side effects. In our case, this function also should remove enemies if they collide, and for that, we write enemyCollision function to handle this logic. We don't need to fill this function right now. All what we need is to assume that this function returns one of the three values: true, false, or undefined. It returns true if there is a collision, and it returns false if there is no collision. Also, it can return undefined. Undefined means that our unit should go out of this map, and in this case, we want to declare a winner. Let's process each output. If the collision is undefined, we want to declare a winner. But again, I want to write a separate function for that, because declaring a winner is another responsibility. Let's create a function setWinner, and we will provide a winner to this function. I write this function, but we also complete it later. Also, in the parameter winner, I use underscore that represents a private variable. Essentially, I put it because we already have a winner in the global scope. And in order to keep the same name, I just put an underscore. Again, we just assume that this function stops the game and declares a winner. And if we call this function, we can also add a return keyword. The return keyword also stops the function when executed. It means that on the point when this function reaches this keyword, it is finished. And we want to finish our moveEnemies function because we already know the winner. So there are no sense to continue our game. Now let's handle the second case, where the collision is equals to true. We also have a shorthand for this if statement, which is just collision without equals to true. So this statement implies that it is equal to true. Now we know that only enemies from different sides can collide to each other. So it means that if we have a collision, we want to remove both units. So I want to set the current tile to a hash. You might think that the variable tile contains the current tile, and this is true, but we can't change our map through this tile. We have the variable raw. This variable is an array. When I access the element in this raw, I actually have the string, so this hash symbol. And tile has a separate cell in the memory where he cloned this symbol. So it means that tile and this hash symbol have nothing in common with our raw. So this is just a clone of one element from our raw. It means that if we change this data, it will not influence our raw. And this is the reason why this tile doesn't change the global map. If I want to change the global map, I actually should add this raw with index of j instead of the tile, and then I should change this element to a new symbol. When I change an element in this way, I actually go inside of the raw with index of j, and then I change this specific index. It also doesn't change or doesn't influence our tile. So it means that even though that I changed this raw to a hash symbol, our tile is still an enemy. So when we create a new variable tile, we put a checkpoint where we clone the data from our array. And then I can change this data, but my tile will not be changed. This is as a checkpoint. I also want to cover one interesting note that is beyond of this video. If you try to store a full array into a new variable, in my case I store raw in a variable raw2, it will not copy and paste this array to a new variable. It will just create a pointer to the same array. All what it means is that raw and raw2 are actually the same variable, and if you change one, it would change the another because it is not a copy, it is just a pointer. I also can represent it in this way where raw2 is equal to raw and is equal to an array. So it doesn't make a new copy, it just creates a pointer, this equal sign to the same array. We won't use it, this is just for your knowledge that you can't copy arrays in this way. So let's return back to our function. So as I said, if we have a collision here, we need to change the current tile to a hash map, and then we also need to change the next tile to the hash map. For that, let's take the next raw. I maximize this window to write this function. If we access the current raw with the index of I, we can access the next raw with the index of I plus 1. J is an index for column, so we are on the same column, so we can just use J without any changes. And now let's write our final condition where the collision is equals to false. In this case, we don't have any collision, so we want to remove the enemy from the current tile and set it to the next tile. I set the current tile to a hash symbol, then I access the next raw, and now I set the next raw with the index of j to e. I know that this was a difficult part, but with experience you will understand it better and it will get easier. In the previous part we wrote functions for adding units and moving enemies. In this part we will finish with ally movement and units collision. So let's start from the enemy collision. This function should return true, false or undefined to indicate the collision result. To understand the collision's result, we need to look at the current tile where our enemy is, and then we need to compare it to the next tile on the same column. As I said, we need to know the current tile and the next tile. For that we can pass the current tile's indices to the enemy collision function. I write I and j. Then we need to take these parameters in this function, so let's also add I and j parameters. Now we can find the next raw on the global map. To find the next raw, I use I plus 1 index. So if you look at our map, I is responsible for rows. For example, we are on the tile with indices of 0 and 0. If I want to find the indices of the next tile, I need to add 1 to the current index of I, so the I index of the next row is 1. And if you look at J, I don't need to change it because we are moving in the same column. Then we have a tricky moment because the next row can be undefined or an array. For example, if we are on the last row, the next row is undefined. This is important to consider because if you try to access the undefined value by any index, you will get an error. This is the reason why I need to handle the undefined outcome before accessing the next tile. So if the next row is undefined, we return undefined. And then our moveEnemies function calls setWinner function and stops this function with return keyword. This is a very important point that you need to understand, that after this check, our next row can be only an array from our map. And now I can access the next tile that will have one of these values. Let's process the case when our next tile is a hash symbol. Hash symbols represent the ground of our map, so it means that we don't have any collision and we need to return false. If our next tile is equal to A, it means that we have a collision and we need to return true. And now you might think that we have one more case. What if our next tile is equal to E? Do you remember how we built the moveEnemies logic? Our function moves enemies down, starting from the last row and moving to the first row. So it means that if we have any enemies on this row, we move them down and then we go to the next tile. And in this way, we guarantee that two enemies can't collide. In our code, it means that our next tile can't be E. Now we have finished our enemy collision function and we can start from the writing setWinner function. The setWinner function is a side effect function. It means that it doesn't return anything, it mutates the existing data in our code. For example, our enemy collision function is a pure function because it takes the data and generates a new data based on the previous data. So it doesn't mutate our current data. Pure functions always return something. As our enemy collision function, it returns true, false, or undefined. Side effect functions can return something, but their main purpose is to mutate the data. Like here, our setWinner function should set the global winner and then log to the console the message that you win or you lose. In our first line, we set the global winner to our local winner that we pass to this function. Then we compare if the global winner is equal to E, it means that the enemy wins this game. So we have the console log that you lose. And otherwise, if the winner is equal to A, it means that ally wins and we have the message you win. We wrote several functions, but we haven't updated our game loop yet. Let's add them to the game loop and see how it works. At this point, we draw the map and then we have a pop-up message where we can put the index for ally. For example, I put 0 and then I don't see any changes. This is because when we call addAlly function, we have a break keyword after it. So we don't draw a map again. I add a new function drawMap and now if I pass the index, you see a new map and in the end of this map, we have A for our ally. Let's also add enemies. So after addAlly function, I will call addEnemy function. Now, if I refresh the page, I have the same message where I can pass the index for our ally, but on this time, you see that we generate a map with both ally and enemy. Then we have a function for enemy movement. So after addEnemy, let's call moveEnemies. I do all the steps again. And now you see that we have a map with both enemy and ally, but on this time, our enemy is moved to the next tile. It means that our moveEnemies function works correctly, but let's also test the collision function and setWinner functions. To do it, I remove the break keyword. I will also remove drawMap function because when we start a new game loop, we started from the drawing a map. And now I have the same message. I will provide the index of 0. And now you see that our map have been changed and I again have this pop-up. So I will provide another index, for example 4. Now you see that allies don't move, only enemies are moving. So now we have a state where two units are very close, and in the next cycle, the ally from the second column will be removed. And now you see that we have only one enemy and we don't have any allies on the second column. So it means that our collision works correctly. And let's make our final cycle to see how setWinner's function works. Now you see that the enemy reaches the end of this map, so it means that the current winner is equal to enemy, and if I provide any index, I have the message that you lose, and this game stops successfully. We have checked all three functions and they work correctly, so it means that now we can write our movement logic for allies. Before writing the movement logic for allies, let's draw how this logic looks like. We can take the same logic as we use in enemy movement function, but in this case allies are moving up, so it means that we need to check from the first to the last row. So for example, we start from the first row and we see that the first row doesn't contain any allies. So we go to the next row and we see that in the third column we have an ally, so we move him up. Then we go to the next tile and here we also have only one ally, and now I can easily move him up because I know that on the previous row I can't have any allies anymore. And in this way works our ally movement logic. Move allies function is very similar to move enemies function. So let's try writing it on your own. But now let's write it together. After the enemy collision function, I start a new function. As we had in our move enemies function, we need to have two for loops. The first for loop for each row. And I start from the index of 0 because we go from the first row to the last row. Then I write the second for loop for our tiles. Now instead of I use J because this is the convention for 2D arrays. Then I need to check that the current tile is equal to ally. If this tile is equal to ally, it means that we want to move him up. At first we need to check the collision. Let's also declare ally collision function. We will implement it later. As in our move enemies function, ally collision function also can return only true, false, or undefined. So we need to process each outcome. I start from the undefined because in this case we need to set a winner and then stop this function immediately. I use the same setWinner function as we used for move enemies because this is a universal function and only one thing that I need to change is the argument that I send to this function. If the collision equals to false, it means that we don't have any collision, so we need to remove the unit from the current tile and then we need to set him to the next tile. I also have a shorthand for collision equal to false, so I use this shorthand. For the last case, I can write else statement. Else statement means that we have the collision, so in this case, we need to remove the unit from the current tile and the unit from the next tile. Then we need to complete ally collision function. This function is also very similar to enemy collision function, so try writing it on your own. So to detect the collision with the next tile, we need to access the next tile. Next row can be undefined, so it means that I need to process this case before I access the next tile. And now I can access the next tile. If our next tile is equal to hash symbol, we return false. And if our next tile is equal to E, we return true. With this function, the case where the next tile is equal to A is impossible. Now let's add move allies function to our game loop. And now let's test how it works. I start from the empty map and I have the pop-up to pass the index for an ally. Again, I pass 0. Now you see that the enemy is moving on the third column. I will put my unit there. I see that my unit doesn't move, so it means that our move allies function doesn't work correctly. If I look at this code, I see the reason why we have this problem. The reason that I take the next row with the index +1, but I want to move my units up. It means that I need to decrease the index by 1. Now I decrease the index for the next row. Now if you try this game, you will see that you immediately have the winner. And this is because in our ally collision function, we need to subtract 1 from the map array. I have also refactored the game loop, so you can just copy and paste it. And now let's test it. I pass 0 for the first unit, and now you see the map with 2 units. I pass another index, and you see that we have generated a new unit on this map, and also our previous units have been moved. I pass another index, and now you see that on the second column we should have a collision. So we have passed this collision successfully, and my units from the first column have almost reached the first row. I see that enemy defends this line, so let's play a bit more. And eventually I have reached the first line, and we have the message that you win. My congratulations, we have finished the first version of this game. We will refactor this game in the future, but for that you need to learn more about JavaScript. In the next video, we will learn about advanced math operators and how to use them in JavaScript.